Welcome back, boys and girls. It's your main math man, Mr. Shank, coming to you live from Walker Grant Middle School. And in this video, we're going to be talking about that real number system. And I like starting the year with this because it's brand new to everybody in Math 8, and it's a good way to kind of expand your mind on this. And so the way I want to start this out is I want you to think about your geography. And what I mean by that is, think about where you're located. And what I want you to do is, all right, think about, your house, or, if you're at school or wherever you're at, and think about, okay, where is that located? So I'll demonstrate for ourselves. So if I say, all right, I'm starting out in, try that again, in Fredericksburg, let's say. And so now I think about, okay, let's go a little bit further than that. Where am I at? I'm in Virginia. Okay, go outside of that. What's the next level? It would be United States. Okay, so now you kind of get in the pattern of this. You can kind of think, okay, well, I'm going to be in North America. Go outside of that, I'm in Western Hemisphere. And if you notice, each of these are inside of each other. So again, you would say that Fredericksburg is in North America. Again, those are contained within each other. And so one step further, I'm on Earth. Luckily for us, it's going well. So now, what I want to do is I want to say, okay, each of those places, those are different groups that we have. You have on the outside, you have a planet, so inside of that you have your hemispheres, your continents, your country, your state, and your city. So notice how, again, that city, even though it's really, really tiny, it's a small group of places, it's still in, this bigger group of ideas. So I want you to keep this in your head as we talk about the real number system, and you'll see why I kind of talked about it here. So now we're going to say, okay, what is a ratio? Well, a ratio is a comparison of two numbers through division, and we're going to say that's going to be in the form of A over B, where A and B are integers and B is not equal to 0. And so you'll see, hey, that kind of looks like a fraction to me. And that is very true because, again, those are integers. Maybe you remember that word from before, but all we're just talking about is a ratio. It's a fraction. So now we're going to say, all right, underneath of that it says a real number system. Okay, any numbers that we talk about this year or in Math 8 are going to be real numbers. And what that means is they're going to be split into two main groups, and what those groups are called are subsets. And the way, well, maybe I don't know what that word means. What does a subset mean? Well, let's break it apart. What does a sub mean? Well, I'm not talking about a hoagie or a sandwich. I'm talking about that prefix sub. So that means under or below. And so a set is a group of numbers. So if you have a set, that's a group of numbers. A subset is another group of numbers under that original set. So now we're going to say, all right, two main groups that we have are irrational and rational. And what I first start off with is I want to underline and make sure I have, okay, hey, that IR, that's another prefix. And so I'm really bringing in my English skills here. I know it's not the best English, but I try them out from time to time. And so I'm saying that IR, that prefix means not. And so what that means is this. It means that it is not in the form of a ratio. So any number that is irrational or not rational, it can't be a fraction. Okay? And so more importantly, when we look at the decimal form, it has to do two things. It must do two things. It must not end, that means terminate, and it must not repeat. So again, for this decimal form, whatever number we're talking about, if we look at that decimal form, it must not do both of these things. If it does one or the other, we're going to have a rational number, which we're going to talk about in a second. But you want to make sure you're trying to see what that means. And I'll give some examples later on. So usually also you can say it's a square root of a prime number. So make sure you're kind of thinking about, well, how do I do square roots? What are prime numbers? And so just make sure you're thinking of that. Again, take a square root of a prime. Again, a prime number cannot be divisible by any other number except itself and 1. So now, okay, irrational numbers, not a ratio. Okay. However, for rational numbers, notice how I have the word ratio in there. Again, ratio, we're talking about a fraction. And so we're going to say, all right, it's numbers that can be in the form of a ratio. And so we're going to say, well, what does that decimal form look like? So it either repeats or it ends. So again, this is the huge difference. That's why I have them in 2 different colors, because we're saying, okay, for not rational numbers, they must not end and they cannot repeat. However, for rational numbers, they can do either of these. Okay, so if they do one or the other, it is rational. So make sure you're pausing, replaying, use the closed captioning. Hopefully it's accurate, but make sure you can understand these ideas. And so now, when we're talking about that first subset underneath of our rational numbers, we're going to be talking about our integers, and hopefully you remember some ideas from Math 7 from this, but we're talking about the numbers that are contained inside of the rationals. So make sure you're thinking about those groups that we had before and how they're inside of one another. So again, these are integers are contained inside of the rationals, and we're going to say that it's the set of whole numbers and their opposites. And what does that mean? Well, I can't just say the positive and negatives. I need to talk about the numbers on that number line. So it's all the numbers and their opposites. We include 0 in there as well. And so what do we change? Well, when we went from the rationals to the integers, what did we take out? We took out the decimal values. So any number that has values after the decimal place, if it's 0.3 or 0.8, whatever it is, if there's any of those, we can't say they're integers. So make sure you're seeing those small differences between each of those subsets. And so now, inside of that, we have the whole numbers. Again, those are contained inside of the integers. And so we want to say, well, what are those going to look like? Well, those are just the counting numbers and 0. So make sure when you're able to count, hopefully by now you've mastered that. But we're going to say, all right, we're including the counting numbers and 0. So all we did was we just took out the negatives. So when we went from integers to the whole numbers, we took out the negative numbers. We're trying to be a wholesome group here. We're trying to cut out all the negativity in our lives, and so we're only going to have 0. So we're just going to be neutral, and we're going to be our positives. And for the smallest subset that we talk about in here, we're going to have the natural numbers. Again, those are contained within the whole numbers. And so those are just the counting numbers. And so what do you start with when you count? Well, if you start counting, you should say, 1, 2, 3. So what do we take out? We took out 0. So make sure you're seeing that main difference. The main difference between the whole numbers and the natural numbers is 0. 0 is included in the whole numbers. However, natural numbers we do not include. Again, you can maybe remember it, but there's the O in whole kind of looks like a 0, so you can maybe think of it that way as well. So now, on the back of this, should have this little diagram on these notes, and what I want to do is I want to have some examples for your real number system. So we're going to say, okay, this is going to be all of our real numbers, and so you notice how it has this kind of diagram. It could be circles, shapes, triangles, pieces of pizza, whatever it is. For this case, it's some rectangles. It doesn't matter, but you have to say it is contained within this. So all these numbers are real numbers, and what I'm going to do is I'm going to break down each of these groups again, and I'm going to say some examples for those. So we said, okay, we have those irrational numbers. They're all on their own island, all by themselves, but they're still real numbers. However, they're all by themselves, so they're all on their own island. Again, those are the numbers that are not rational. So an example of that, we set a square root of a prime, square root of 17, since 17 is prime, and we can also prove it by looking at that decimal value. So if you bust open your Desmos calculator, you can say, all right, I want to take the square root of 17, and if you notice there's no real pattern, again, the numbers would keep going. If you wanted to use another calculator, you would see, hey, those numbers go on for infinity and beyond. And so another number of that is a classic one. If you notice that, that is a Greek letter. That's not a messed up T or anything like that. It's not a table. It's pi. And I'm not talking about pizza or the fruit pie. I'm talking about the Greek letter pi. And what does that number stand for? Well, it is approximately 3.14159, and so on and so forth. And so again, similar situation. There's no real pattern to those numbers. Again, it does not end, and it does not repeat. And so you could say, okay, well, just another random number. We're looking at this decimal form, and it would say, okay, we got 4.12 4.1287, and then what do these three dots mean? Well, that just means those three dots means the numbers keep going. And so make sure you're thinking of that. It's not, another decimal place or anything like that. There's no comma here. So we're saying that these numbers keep going. There's no pattern. It does not repeat. It does not end. Therefore, it is irrational. Okay, so all those numbers are all by themselves. We have to make sure that it cannot repeat, it cannot end. However, for the real numbers that are rational, again, those can be in the form of a ratio. For example, we can have 5/7. Again, notice how those are two integers being compared through division. That's that line in the middle is that fraction bar. We can have a normal decimal. Again, this decimal ends, so therefore it is rational. You can also have a decimal like this. It says 71.3. repeating, and so make sure you see that line above it. Again, that line above either one number or several numbers means it repeats. It could also be in the form like this. It would be that 7.3333 or 71.3333. Again, notice how it says same idea. Those three dots mean it keeps going. However, since it has that same pattern of numbers over and over again, it means it repeats. So contained again within those rational numbers are our integers. And so maybe an example of that, you check out a number line and say, hey, maybe -13, -18, +18. So again, those are the whole numbers and their opposites. And speaking of those whole numbers, again, those are contained within those integers. And so what do we take out? We took out the negative numbers, and so maybe an example of that I could say is, would be 0, 1, 2, 3, so on and so forth. Again, the dots mean the numbers keep going, but notice how I have a comma here. So our next number would obviously be 4, then after that would be 5, so on and so forth. And lastly, we have our natural numbers, which when you start counting, you count with 1, 2, 3, so on and so forth. So again, make sure you're thinking about those differences. You're thinking about how they are compared to one another and how they are related. So again, at any point, make sure you can pause, rewind, and recap. So close it out with this. I want to say, what is the main difference between the whole numbers and the natural numbers? Well, we said that the whole numbers include 0, but the natural numbers do not include 0. And so again, to have that screen cap from before, notice again you have the whole numbers include 0, however the natural numbers do not. And as always, be sure to super slam that subscribe button.